Okay, lesson 2.6. We start talking, it's called families of functions, but we start talking about translations, reflections, stretches, compressions, how we move functions around. And I know you guys all had that formula sheet from the quiz that you used, and down at the bottom there was this big section, and it talked about moving things around and whatnot. That's where we're at. We're talking about transformations. So as we look at this, I'm going to tell you that transformations are a theme in Algebra 2 that keep coming back. Okay, we're going to use them this chapter, and we're just going to be moving a variety of graphs. Okay, we will use them when we get to lesson 2.7, most likely with absolute value graphs. There'll be another chapter down the road where we'll use them with parabolas when we talk about the quadratic graphs. So we'll use them throughout the year. So that list of transformations you have on that formula sheet is going to keep coming back. The more we use it, the more you'll become familiar with it. Now, the ones we're looking at here, just some basic transformations and reflections. First of all, if you're trying to figure out what that's supposed to say, that is supposed to say f of x. So that's just saying, when we talk f of x, we're talking a function. So, some function. And the idea is, if you add a number, a constant, to a function, that is going to take the function and move it up. So if you add c, that means you're going to move the function up c units. If we add 5, that means we're going to move the function up 5 units. Okay? If you subtract a number from a function, that means you're going to go down so many units. Okay. Now, notice what's different about these next two. It's still x plus c and x minus c, but now the plus c and minus c are in the parentheses. So if your number added or subtracted is in the parentheses, under the square root, in the absolute value bars, notice instead of going up or down, we're going to go left or right. Now, notice, when we go up, it's plus c. That seems normal to me. When we go down, it's minus c. That seems normal to me. I'm hopeful it seems normal to you all as well. What do you notice on these? When you add c in the parentheses, what do? You go left. Kind of backwards, isn't it? Okay? When you subtract c in the parentheses, you're going to go right. So I always remember my parentheses are left and right, but it's opposite the direction the sign is. So it's opposite what you'll expect. Okay? And we'll talk about some other ways as we go to remember that. Did I answer your question in there somewhere, Eli? Okay. I was getting to you, I promise. I just was waiting for a stopping point. Okay, reflections. Two different types of reflections here. If there's a negative sign multiplied by the entire function, that is going to be a reflection in the x-axis. So if you're multiplying the whole function, that's a reflection in the x-axis. If the negative is just on the x, that is a reflection in the y-axis. That's kind of an opposite thing to me, because if it's on the x, the negative's on the x, we reflect in the y-axis. If it's on the whole function, well, f of x is like a y value, then you reflect in the x-axis there. Yes?
Does this happen this way, where we're like taking a function and multiplying? Why does this, like, I've never understood this, why does algebra visually represent, like, equations on graphs? How does this,
Well, I mean, it depends on what you're doing, because if you multiply something by a negative, like if we multiply the x value by a negative, normally a positive x is going to take us right on the graph, but you multiply it by a negative, now it's going to have to go left on the graph. Or, you know, if you, I mean, it just...
So multiplying by a negative would take that point right to its negative counterpart?
The opposite direction.
Okay.
I know it's abstract right now because I'm just kind of generally explaining it, but we'll get into some specific examples. Okay? I'm just trying to get the general table out there so you can have an idea of what each part means. Yes?
So when you say reflect in the axis, is that the same as saying across the axis?
Yes.
Okay.
Yes. So when I talk about, so if we say reflect across the x-axis, which axis is your x-axis? Horizontal, yes. So if I'm reflecting across the x-axis, that's taking something above my x-axis and flipping it below, yes? And if we're reflecting in the y-axis, the y-axis is your vertical axis. So that's taking something and reflecting it left to right, right to left. Does that make sense? Does that answer the question? Okay. Okay. And then the other thing we're going to talk about, this book uses the terms stretch and compression. I don't remember if you've heard stretch and compression or stretch and shrink maybe. Okay. But the idea is if you have, in this case, they use an A value. But if you have a number multiplied by the function, it will either stretch it or shrink it. If you multiply by a number that is greater than 1, then it's going to be a stretch. In that case, it could mean making something taller. Okay, it's going to stretch it up. If you multiply by a number that is smaller than 1, and of course these are both positives, then it's going to be a compression or maybe a shrink. So it's not, I guess I shouldn't just say smaller than 1, a number between 0 and 1. So those are like your decimals and fractions, right? Like multiplying by 1/2 or 0.3 or whatever the case is. That's going to take it, and I think on a graph of like a stretch or compression, compression or shrink, like pushing it down more, compressing it. Okay? So we'll get to visuals of all of these at some point, okay? Whether it be today or another day, because we'll definitely, when we go in to do absolute value, we'll have lots of visuals there. Okay? So, the front of this page, we're talking about the translation. And again, I want to try and draw some connections for you. I don't know if I can get that all on the screen that I want there. Example A. How are the functions y equals x and y equals x minus 2 related? And how are their graphs related? So thoughts about y equals x and y equals x minus 2. Excuse me. Thoughts, Carter?
I think it's just translating 2 units.
Okay, he says translate 2 units to the right. What do you say, Jacob? Okay, they are going to be parallel. How do you know they're parallel? Same slope. Mm-hmm. Now, officially, okay, so Carter says 2 units right, and I can't argue that one here, because I could put a set of parentheses around this problem, and it would be 2 units right. And this is a special case because it's a line. So we could say 2 units right, but what's the other thing we can also say? A minus 2 just on the function is what? Going down 2 units? Okay, so on this particular problem, and again, it's because we're talking just a straight line, that we could either say, you could say right 2, but I was looking more for down 2. Okay? Because I want to draw some connections, trying to decide how I want to do this. Sorry. Again, the first one I'm going to make lots of connections. Let's compare an XY chart, if you would. So if I make an XY chart here, what are good X values to use? 0. Okay. -1. Is it good to get negatives and positives?
Yeah.
It is. Okay. I'm going to use -2, -1, 0, 1, and 2. And this is for my first equation, y equals x. So if we're using that equation, y equals x, if x is -2, what's y? -2. If x is -1, what's y? -1. If x is 0, 0. If x is 1, 1. If x is 2, 2. Okay. Let's do the same thing. Let's make a comparable XY chart for my other equation. This time using the equation y equals x minus 2. Guess what I'm going to do in terms of x values? Same ones. Again, I'm trying to make a comparison here. Okay. This time, if I put in -2 for x, what is y?
X minus 2.
Right, but, so if I put in -2 for x, we're going to do -2 minus 2, which is -4. Okay? So if I put in -1, putting in -1 in place of x, -1 minus 2 is -3. 0 minus 2, 1 minus 2, and 2 minus 2, 0. Now, the connection I want to make here sorry, I was trying to focus and it goes a little psycho sometimes. What do you notice? Okay, so our inputs, our x's stayed the same, yes? What happened to the outputs each time? If we compare equivalent outputs. So -2 and -4. -1, -3, 0, -2, 1, -1, and 2, 0. What's the connection between the outputs each time? Each time my output was subtracting 2 or was 2 less, correct? And that is part of the difference when we talk about how are these functions related. Well, each output of y equals x minus 2 was 2 less than that output there. And again, that's one of the connections I want to make is that the outputs, because it's the -2, those outputs are 2 less. So I am going to write that down. Each output of y equals x minus 2 is 2 less than the output of y equals x. And that's part of my first answer. Now, it also talks about how their graphs are related, yes? And we kind of already talked about it. I'm going to put a physical graph here for the visual. And I'm not going to do this on all of these, but let's see. What do we need to be able to go? Need to be able to go 2 right, 2 left, 2 up, and I think 4 down. I guess if you're sorry if I'm not giving you guys enough information on spacing, I am going to write one other little thing about the graph off to the right. Sorry, I'm not showing you my whole screen, so you probably don't know where I'm at on spacing. If we graph each of these, let's compare the graphs. The first one, so I do the one that I did in my red here. -2, -2. So that's going to go left 2 down 2, -1, -1, 0, 0, 1, 1, and 2, 2. My first line looks something like that. Oh man, I missed a dot. This is why I don't like to freehand. I'm not very good at the freehanding part, but it'll work. Now if I do my blue points, -2, -4. Notice that point is 2 below the other one, yes? -1, -3. Left 1, down 3. Again, 2 below the point above it. 0, -2. 2 below it. 1, -1. And 2, 0. Yes, I ended up with parallel lines, but I also ended up with lines that are 2 apart. Technically, I'm going to think that it's 2, but they're 2 apart vertically, that the one moved down 2. However, we could argue that they are 2 apart horizontally as well. And so, how are the graphs related? The graph was translated down 2 units is where I was going with this part. The graph is translated down 2 units. Yes, I do. Are you okay with tape? Okay. Did you guys get everything you needed there? Again, I'm not going to go into as much detail and write all this out on all of them, but there's a lot of connections to be made here. Okay. Everyone caught up almost? Okay. What is the graph of y equals x squared minus 1 translated up 5?
I don't know what my brain is now, okay. Because now
You want?
I have no idea how I messed this up or why.
I think this still works. I think I have some corrections. Yeah, you can reel it. You can reel them back in, so I'll reel it back in. It's fixable, as long as you don't do what my daughter did, where she cut it off.
Oh.
And I was like, I can't fix that. She messed one up, and she was like, "Oh, I'll just cut it off." And I was like, "No, you can reel them back in, but you can't tape them back together, so to speak." So, okay. So, what is the graph with y equals x squared minus 1 translated up 5 units? How do we translate something up 5 units according to our chart? U plus 5, yes? According to what it says up there, we're going to add 5. And if you look up there in the chart, let me scoot up for a moment. It just says what? Up C, you just add that number on the end. So what are we going to do here? We're going to take, what was our original graph? Y equals x squared minus 1, and what do I need to do to it? Add 5 to it. Now, the question becomes, is there some cleanup you can do here? Yeah, what can I clean up? Yeah, these are like terms, so to speak. -1 plus 5 is going to make this the graph. Y equals x squared plus 4. Yeah, now you just have to wait for that one to dry, unfortunately. But
I am sorry about the tape.
oh, you're fine. It's fixable.
There are no accidents.
Okay. Questions on this one?
So we don't even have to make a chart.
I'm not going to. I could. Do you guys know, let's see how much algebra 1 you remember here, what y equals x squared is a graph of? Do you know? One of those curvy things. It is one of those curvy things.
Parabola.
Parabola?
Knew it.
Yeah. Okay. So, and you guys did some with parabolas back in Algebra 1. I promise you did. I know, 2 years ago for most of you, but still, you did some with parabolas. I call them the U-shapes. Okay? But that's what y equals x squared is. So y equals x squared minus 1 is a parabola that was moved down 1. But then what does the plus 5 do it?
Moves it up.
Takes it from that minus 1 and moves it up 5. And so now that's a total displacement of 4 because it has moved up 4 total. Okay? So, yeah, again, I could graph that, but we've got tons to do when we'll get graphing eventually. Okay, so part C is just like question A, except that we're not going to write it all out this time. We're not going to do all the details. We're going to kind of anticipate. So this is just like question A. They want to know how are these two functions related and how are their graphs related. So let's use the information from above. If this is y equals 2x and this is y equals 2x minus 3, what do you expect about the outputs? If we're talking about how the functions are related, what do you expect is going to be true of the outputs? Excuse me. Abby? Yeah. Output of 2x minus 3 is going to be 3 less than the y equals 2x. Okay? So that's one thing I'm going to write, is that the output, and actually I'm going to shorten it and just say the output, I should have said each output, well, the output of y equals 2x minus 3 is 3 less than output of y equals 2x. And then, when you're ready to think about it, how are their graphs related? If each output is 3 less, what's that do to the graph? Moves it down 3. Okay, we're still going to have parallel lines, aren't we? So, I'm going to say the graph is, now, I said moved down 3. What's my better algebra word than moved? Translated, thank you. So the graph is translated down 3 units. Yes?
So, could we have a parallel line that was like squiggly?
It wouldn't be called a line if it's squiggly.
You know what I'm saying? Like, we have like,
Parallel shape, so to speak. I don't know if you'd call them parallel or not at that point.
it's just a.
I understand the question. I just don't know if you call it parallel there. Okay. Last one on this side. What is the graph of y equals 3x translated up 2 units? How do we translate up 2? You add 2. And we add 2 to what? To the equation, right? So if I have y equals 3x And then I add 2. What is y equals 3x plus 2? Y equals 3x plus 2? Okay. So that's a little bit about vertical translations there. Okay. Several things to look at on the back. Horizontal translation here. Okay, horizontal means we are talking about left to right, yes. Given f of x, whose graph is drawn, find the values on a chart for a translation, write 5 units. So, first of all, can you guys identify what these points are here? You kind of have to be, let me go ahead and let's write down what these values are. That first point you can tell is what? 1, 1. What's this point right here? 2, 2. Okay. What is my peak at?
Looks like 4, 3. Wait, 3, 4.
Reverse it and say 3, 4.
That's what I'm doing.
Okay. What's this next point at? 4, 1. And the last point is labeled at 5, 1. Okay. I just wanted to give you guys a visual so you knew what all those points are. Because I can only zoom in so much here. Now, it asked us for, how was it phrased? Find the values on a chart for a translation, write 5. So what do these points look like when you move them, write 5? So if I take this point 1, 1, and I move it right 5, where does it end up? 1, 2, 3, 4, 5. Where is that ending up? Not 6, 6.
6, 1.
6, 1. Because we are only moving it horizontally, yes? This is why we're doing the visual and the graph. So if I take the point 2, 2, and I move it 5 right, where does that end up at? 7, 2. What's the shortcut? Add 5 to only the x's. Because when you move something left or right, what's changing? Just the x. So 3, 4 becomes 8, 4. 4, 1 becomes 9, 1. And 5, 1 becomes 10, 1. So that is your chart of values. And we did that just by taking our x value and adding 5, correct?
So, Mr. Sargent, not that it's in this question, but what would you put as the formula? Something like F?
It says to the right, it would be right would be f and then x minus 5. Would that be it?
It would be f.
Plus, like,
Okay, so it would be f of x minus 5, where the x minus 5 is in the parentheses, if that's what you're asking.
yeah, that's
I mean, we don't have an equation. I mean, that's not, that mountain shape doesn't have an equation to it. But if you just use general f of x,
okay, that's what I was asking.
since we moved right 5, that would be expressed as f of x minus 5. Okay? Okay. You'll get more about horizontal translations in homework. Make sure, remember, when that's in the parentheses, go opposite the sign, opposite direction of the sign. I'll get it right here. Okay, shall we reflect? Let's do some reflections. Let g of x be the reflection of f of x equals 3x plus 3 in the y-axis. What is a function rule for g of x? First of all, when we say function rule, have you figured out what I want yet? When I'm looking for a function rule, I'm basically looking for an equation. So whether you see that on a quiz, on a test, in Math Excel, coming out of my mouth, excuse me, the function rule is, okay, give me an equation. Now, it's asked for a reflection, right? And it's a reflection in the y-axis. If you look back to the front, what did it say about a reflection in the y-axis? It said to do what? F of negative x, where the negative is on the x, right? So if we're going to rewrite this equation, so it's a reflection, it was f of x equals 3x plus 3. Now, every place I see an x, I'm going to replace it with negative x. So instead of saying 3x plus 3, I'm going to say 3 times, what am I putting in place of x? Negative x plus 3. Clean that up. What would be 3 times negative x? Negative 3x plus 3. Notice, by reflecting in the y-axis, what's the only thing that changed? The sign on the x term. Now, it said, what is the function rule for g of x? It told me a couple different times to name this g of x. So I'm going to say g of x equals, what do we come up with? Negative 3x plus 3. Okay, what about this other one? This next one says h of x. Reflection where this time? X-axis. And again, they want a function rule. How does it say to do a reflection in the x-axis according to the front side of your notes? Negative f of x. So this time, my negative isn't going on just the x, it's going on everything. So I think of this as, I'm going to take negative, and I'm going to multiply it by that whole equation. So it's like I'm going to take a negative and I'm going to distribute it into each part. If I take a negative and distribute that, negative 3 or negative times 3x becomes negative 3x. Negative times the plus 3 becomes minus 3. Notice in a reflection on the x-axis, not just the x sign changed, but everybody's sign changed. Told me to call this h of x, so I'm going to say what? H of x equals negative 3x minus 3. Okay. And again, you'll get a variety of practice in the homework. Okay. Ready to talk stretching and compressing? Okay. The table below represents the function f of x. What are the corresponding values of? And so in this first one, they ask for g of x. And what does it say to do? 3 f of x. Is this going to be a stretch or a compression? Why a stretch? Yeah. Because, so our a value is 3. What is it we're multiplying by? That's our a value. And 3 is exactly that, bigger than 1. So this is going to be a stretch. You would say it's a stretch by a factor of 3. Now, what is it I'm going to multiply by 3 to get this stretch? It says 3 times f of x. Well, what are my f of x values, so to speak? Those are my y values. And I'm kind of pointing off the screen, aren't I? So to do a stretch of 3, the only thing that changes are these values right here. We're going to take, it's 3 times f of x. So each of your f of x values you're going to multiply by 3. 2 times 3 is 6. 2 times 3 again is 6. Negative 3 times 3? Negative 9. 1 times 3? 3. Negative 2 times 3? Negative 6. Now, try this again. Okay. I'm going to write a horizontal chart out here so we can put this all together. In that, we only change the f of x values. What are my x values? They're the same, yes? So earlier it was 5, 2. Now, for this g of x, it's going to be 5, 6. It was negative 1, 2. Now it's negative 1, 6. It was 6, negative 3. Now it's 6, negative 9. It was negative 5, 1. Now it's negative 5, 3. It was 4, negative 2. Now it's 4, negative 6. Those are my new corresponding values. And that was doing a stretch. Your stretch or compression is just changing those y values. These are vertical stretches and compressions. Can we do the other one? What's the difference this time? They want us to call it h of x, and it's 1/3. What's 1/3? Okay. That is what we're going to call a compression. It's a number between 0 and 1. Now, you're going to kind of have to block out these other numbers because now I want to do 1/3 of each y value. Now, we're not using these new ones, so block them out for a moment. We're going back and using 2. How do you do 1/3 of 2?
Teachers, pardon this interruption. For the rest of the day, Mr. Westrum's classes, you are going to report to the same class that you were in yesterday, room 108. You need to bring something to work on. You will not be allowed to go to the hall to your lockers. You must bring something to work on, please. That's the rest of the day for Mr. Westrum's class. Thank you.
Okay. How do we multiply 1/3 times 2?
Put it over a 1.
Put it over a 1, and this is going to become what?
2 over 3.
2 over 3. The next one was 2 again, right? So 1/3 times 2 is again going to be 2/3. What's the next number? 1/3 of negative 3 is negative 1. You're just, and really when you do 1/3 of something, what are you really doing? You're just taking and dividing by 3. What about 1/3 of 1? 1/3 times 1 is going to be 1/3. And the last one, 1/3 times negative 2 is going to be negative 2/3. So again, I can express it as a chart. Original ordered pair was 5, 2. What is it now? 5, comma 2/3. I did have negative 1 comma 2. Now it's negative 1 comma 2/3. I did have 6 negative 3. 6 negative 1. Negative 5 1. It's going to become negative 5 1/3. And it was 4 negative 2, which is now 4 negative 2/3. Again, all of that to remind you, a stretch or a compression is just changing your y values. Okay, I am obviously at a time crunch. And I didn't pull the homework up and look at it this morning, so I'm trying to remember how much this affects. And I feel like it does affect, but I don't remember exactly. So what I'm going to say, yes, I want the homework due for tomorrow. Yes, I want you to go through and do it. Might there be a few that relate to this last problem that you might struggle with? There might be. We can talk about that tomorrow if it is an issue. And I don't remember off the top of my head. So I may or may not do some of these notes tomorrow. Undecided at this exact moment. However, regardless, the homework is still due tomorrow. If you come with a couple that you have questions on, we can get those taken care of. Am I making myself clear here?
Yeah.
I don't want anyone to come back and say, oh, I didn't do the homework. I didn't think it was going to be due. No excuses, right? That's your choice. I think the classmates are going to vouch that I said it, so.
Give you all of them.
I asked you yesterday, did you have a good weekend?